Gentlemen, good morning. I would like to welcome you all here in the room, in the Erasmus building, and those who are following us on ESA TV to the ESA Commercialization Day on Transport. We are about to start with a welcome address from our Director General, Joseph Aschbacher, followed by a keynote speech by the Director of Competitiveness, Industry and Commercialization, Geraldine Naja. Welcome and have a nice and fruitful day.
Esteemed colleagues, dear partners and guests, I'm very, very happy to intervene at this remarkable event, the ESA Commercialization Days on Transportation. It is my privilege to welcome you all on behalf of the European Space Agency. The ESA Commercialization Days on Transportation represent a significant milestone in our agency's mission to push new frontiers of commercialization and collaboration. Today, we embark on a new journey to explore the vast possibilities of space technology in the realm of transportation with key institutions, industrials, and startups from both sectors. Transportation is an essential aspect of our daily lives, from our daily commutes to the movement of goods and services that underpin our economies. The challenges and demands on our transportation systems are ever evolving. The transportation systems become increasingly automated. The demand for efficient and low-emission transport options is in the rise, and mobility as a service platform now plays a crucial role in identifying optimal transportation means. It is imperative that we continually seek innovative solutions to address these challenges. This is where the synergy between space technology and transportation becomes clear. Space technology has consistently demonstrated its potential to shape and revolutionize transportation, whether it is the precision offered by satellite navigation, the traffic monitoring enabled by Earth observation, or the staggering possibilities to adapt space systems to use them in automotive industry. The fusion of space technology and transportation holds the promise of safer, more efficient, and sustainable solutions that can reshape the way we move people and goods. Today, we will develop into various aspects of this dynamic collaboration between space and transportation actors. It is not just about showcasing the achievements of ESA and its partners in this field. It is about sparking dialogue and fostering new commercial collaborations. It is about bringing together two incredible industries to drive progress for the benefit of all humanity. In closing, I would like to express my sincere hope that the ESA Commercialization Days on Transportation will inspire you, ignite new ideas, and cultivate new partnerships among all of us gathered here. Thank you for your attention and your commitment to this important endeavor.
Hello, and welcome to ESTEC, and welcome to the Erasmus building in particular. We are talking today of transportation, mobility. You have excellent examples of transportation to other horizons. But today we shall speak about commercialization in transportation on Earth. And I will first try to make this work. Yes. So why are we here today to talk about commercialization? Because, as you know, in the Agenda 25 of our Director General, who just introduced the day, commercialization also with a green, for the green transition and for a digital transition is a key objective of ESA. And we are absolutely convinced that actually the transportation sector, the mobility sector, will really benefit from space commercialization and from commercial services derived from space infrastructure. And to do that, we have set up a series of transversal activities and services to really encourage new markets, new applications of space-based technologies. And once again, we believe that the transport sector has really very high perspectives for commercialization of space-based services. So what are the three, let's say, what are the three ways in which we have to go? Which are the three directions in which we are acting? They can be summed up by three words: speed, capital, and talent. Speed, because we are into a new space age where we see that everything has accelerated, that everything from the development cycles to the production to the ways we operate services, we need to be faster, we need to be more agile, we need to be quick on the market. So speed is the key. But capital, of course, is also a key, because you cannot do anything without access to funding, and this might be, by the way, a major gap between what we do in Europe and what is happening in the US. We have less easy, direct access to funding, but we are working on that, and I'm happy to say that in our team we have set up a network of investors. We have now signed 40 partnership agreements, so we do work on easing up access to private funding, and I would add access to European investors. But the third word, talent, is perhaps the most important, because in the end, all that we do is invest in brains. And we have to help innovation, we have to help the creation of startups, we have to also provide inspiration, provide attraction to STEM engineers. You know that we are lacking STEM education, we are lacking engineers in Europe, despite the fact that space is growing, despite the fact that industry is recruiting, we are recruiting. We need to really attract more and more students to space. And I believe that, yes, all that we do now in the commercialization sector, all that the new space ecosystem is doing contributes to that attraction. So these are the three keywords of our action: speed, capital, and talent. And the arenas we play in are perfectly embodied by your presence today. Of course, industry, be it space industry or non-space industry, but also anything that has to do with innovation, academia, as I said, students. Also institutions. You are here in the European Space Agency, but we are cooperating closely with institutions such as the European Union, through the European Commission, through the European Agency EUSPA, but also through a number of European institutions. And finally, of course, the space companies I mentioned already. So you see a wide range, institutions, publicly funded, investors, industry, and academia. So what do we do in practice? What do we do concretely at ESA to support commercialization? First of all, we have a number of programs in all our program directorates which are directly related to commercialization. So now all our programmatic activities have a side which is commercially related. So for instance, if you look at Earth observation, there is the InCubed, and they set up the first PhilSat, and now which will transform into a network of PhilLabs in Europe. Operations, we have S2P. Telecoms, of course, a very commercial sector by nature. We have a number of activities related directly to commercialization. Exploration also, because we believe that the next step in exploration will be, let's say, a more private step. We will see, instead of the publicly funded and developed Columbus, we will see certainly private space stations. We will see also the setup of a LEO and lunar economy. Technology, you know the technology programs, GSTP in particular, navigation with Navis, and you know that navigation has become the major sector for commercial space-based services. And last but not least, the enabling fact in any space policy, the key is access to space, and we are working both at stabilizing and, let's say, overcoming the challenges with which we are confronted today in space transportation, but also preparing the future with the support to private launch services in Europe, in particular small launchers, but also preparing the future through FLPP. So you see, all our program directorates have activities which, by the way, may be very relevant also to transportation sector. But in addition to that, we have two transversal programs, I mean BAS and Scale Up, I will come back to that, which are aiming at providing corporate services to all these directorates, but also to industry, space and non-space industry. And I will start with the BAS program. BAS stands for Business Applications and Space Solutions. What is BAS about? Quite simply, BAS is about using the existing space assets in telecoms, in navigation, in Earth observation, to provide integrated applications to non-space sectors and to provide new solutions to issues that we encounter on planet Earth. Obviously, among these issues, you have mobility. And already, as we will see, BAS is working in the transport and mobility sector quite substantially, but BAS is also working on, for instance, space for health, space for energy, and such applications. And indeed, in the, let's say, in the Business Application and Space Solutions program, we provide different ways to make new applications commercially viable. Access to zero equity funding from 50K to more than 2 million euros. Tailored project management support. Each of the projects that we support through BAS is very, let's say, is taken as an individual case. We don't have one solution for everyone. We work with a dedicated project management support. We have a number of networks and partners, and I would say we have quite an important thing when it comes to going to investors and looking for private investment, what we call the ESA brand. So we have a kind of stamp of quality that we declare that such and such projects are really worthwhile investing into, are really worthwhile developing. And with that, we indeed achieve our, let's say, our outcomes, which can be divided in three types of outcomes. First of all, socioeconomic outcomes. So you know that space has a strong socioeconomic impact. The multipliers are in between 3 and 4, meaning for each euro invested in space, we get 3 or 4, depending on the detailed sector, euros of economic impact, of growth, of also we get jobs. Also, better use of space for new markets and user communities, make sure that what we develop is really useful for our societies, and finally, strengthening European industry competitiveness, because this is also something which is our objective. It is even in the convention of ESA since the 1970s. We are also there to support the competitiveness of European industry. And as I mentioned, in BAS, we have a number of activities related to mobility and transportation. More than 140 activities have been supported so far, with two, let's say, main focuses. One is decarbonization of the transportation modes, and the second one is safety, resilience, and sustainability and accessibility of the transport infrastructure. And we address all areas of transportation from automotive, air, sea, and rail, and we will look at that during the day. You will get many roundtables and presentations on these sectors during the sessions. And you will see also several task forces presentation, because BAS also focuses, let's say, works in a series of task forces, and some task forces actually have identified mobility as a major issue. I would just like to quote energy, smart cities, and the maritime sector. These are subject to dedicated task forces in the BAS program, and these are also addressing mobility and transport. Next to BAS, we have the Scale Up program. This is a new program at ESA. It was started last year. And Scale Up, contrary to BAS, is more focused to newcomer entities, in particular startups, but not only. So in Scale Up, we work on two aspects, innovation and investment. Innovation through, let's say, our network of business incubation centers, the Phi Labs that we are also developing across ESA, but also technology brokering, patenting, and investing through our network of investors, and also we propose a marketplace to bring together potential providers of services and potential customers. So if you take together actually Scale Up and BAS, you can see that we work at all steps of the development of new applications and services, from the first idea to incubating. Then we also work with European accelerators, help the, let's say, accelerated companies to work within ESA activities and programs. And then, let's say, the BAS program, which is more addressing established companies with established products. So we have a kind of continuum to really work on innovation and commercialization and business development. And I would like to make a special point on our business incubation centers. They were created some 20 years ago, and actually the first big created is very close to here. It's a few hundred meters from ESTEC. We now have 29 incubation centers in 90 locations in Europe, with some 200 startups selected annually, and already almost 1,500 startups which have been selected and incubated in our BICs. And indeed, you will also see today several big startups which will pitch during the day today. So also a number of BICs and startups are working on mobility, on transportation. And part also of the interest of what we do in these, let's say, transversal services through the Scale-Up program and also with BAS is support to technology transfer. Of course, technology transfer goes both ways, from space to non-space, from non-space to space. But we have a technology broker network, which is, let's say, working closely also with the business incubation centers, and which provides, in particular, technology scouting, but also things such as market analysis and funding for new projects. So with this, I would like to, after this introduction of what we do in commercialization at ESA, insist on the high potential that the transportation and mobility sectors have for us. We think that the future of transportation and mobility, in particular, such as autonomous cars, but also autonomous shipping, etc., will require a very strong and resilient space infrastructure. And therefore, I think that today will be an important milestone to well applying space for transport. Thank you.
Thank you, Geraldine, for your introduction. And now it's time to start the first session of the day, dedicated to automotive. The session will be started by a keynote from Ulrich Herrmann from Einstein Industry Ventures, who will give an overview on the automotive market, followed by the ESA perspective delivered by Elizabeth Leyer English and Roberta Mogellesi Dow, and followed by the pitch session and the round table. I now leave the floor to Ulrich for the first introductory lecture. Thank you.
So, good morning, everyone. Thank you for inviting me. Geraldine, thank you very much, ESA team. I'm very happy to be here today after a very intense time. The last 9 months, we have conducted a study on space-enabled application on the automotive industry, and I'm proud now to present the results of our findings and of our conclusions. My name is Ulrich Herrmann. I'm general partner of Einstein Industries Ventures, which is a late-stage investor investing exactly on the interface between space, infrastructure, and processes in the car industry, in the industry per se, in all sectors, downstream, so to say, to help business transformation, to help understand sustainability outcomes and supply chain resilience. In our study, we had an objective to offer a comprehensive foresight assessment of the automotive sector and aim to evaluate the feasibility of space-based solutions. We have been addressing technology advancement and economic impact, first order and second order, and came to fundamental and substantial insights. The project was focused on the European downstream application exactly at the interface between available space infrastructure and then processes in the car industry to create economic value and competitive strength. Einstein Industries Ventures collaborated with Porsche Consulting and Akitoflux, both specialized consulting companies on the space and the car industry, with strong contributions from the industry, namely SAP, Ergo, and UHB. I would like to thank you for this contribution. That was very, very important. The research team conducted interviews with over 250 senior level executives in the automotive and mobility sector and related industries. So let me begin with what is at stake. The global automotive industry, valued at 3 trillion, plays a central role in the EU economy, supporting 13 million jobs, with Europe manufacturing 20% of global automobile output of or 79 million vehicles per year. This industry considers nearly 7% of EU employment. The industry clearly leads in R&D, investing 59 billion annually, which is a third of the total R&D investment in the EU. Today, as never before, the global players, especially China, challenges the car industry into a dramatic business transformation. There's a lot of opportunity. The automotive industry is in the middle of a transformation driven by the rise of battery electric vehicles and the growth of software-based revenue, potentially increasing the global market from 3 trillion to 5 trillion by 2030. Now, question, of course, is what is the share of Europe? Software is the opportunity for the car industry, but at the same time, it's its biggest challenge. As revenue shifts towards software-based services, opportunities arise in in-car e-commerce, in advanced driving features, in vehicle-to-grid, in-car entertainment, and so forth. This shift necessitates strategic thinking for all OEMs and balancing profitability with the different cost patterns of advanced software solutions. This shift follows a business model pattern observed initially in the media industry, then coming into the software industry, now arriving full ahead in the car industry. And there is consensus. There is not a single manager that we talk to who believes the business comes from mechanical inventions in the future. Sheer everyone who is an executive expresses one way or the other that the future profit pools come along with software. And software, ladies and gentlemen, this is built around data streams. And this is about cloud capabilities, as you all know, utilizing now core space capabilities, which are connectivity, PNT, and Earth observation. And this is becoming suddenly critical for the future in mobility. We are witnessing three major disruption trends in the car industry. First is around the cost. What we need to restructure is the way how cars are built. The internal combustion engine car, the ICE, the bill of material of this car does not include the cost of software and not the cost of the battery. And that is highly expensive. The only way to overcome this is to substantially reduce the complexity of the hardware of the car and the production systems, and on top eliminate the cost associated with the hardware product life cycles. Every 5 years, a new car is released on average on the same model. No one can afford this in the future anymore. Instead of mechanical features, the car industry has to follow the path of the software industry and bring features into continuously updated software, which then is finally displayed on the surface of the car, but not change the mechanical features. The second disruption we see seems to be the biggest challenge, although everyone saw it coming. It's China. China's rapid progress in both the space and automotive industries, positioning itself as a global technological powerhouse. In the automotive sector, China has become the world's largest market for vehicle sales and production, surpassing Japan in exports. This transformation is evident in industry trade shows such as the EIA in Munich, as someone who was there could observe what China was doing there, omnipresent. The dependence of the EU car industry on China is strategically established by Chinese regulatory authorities, coupled with challenges in repatriating profits back to Europe. And that leads European players to reinvest profits in China, ultimately promoting dependency and capacity expansion in China. Europe's strategic autonomy is at risk, particularly in the automotive sector. Last but not least, connectivity. As in the final third disruption we observed, connectivity becomes the blood and oxygen for the software-based car industry. And thus, we can't play around here. Connectivity, 100%, 24/7, is in the center of every software business. And here we see the next disruption at the telecoms, forced into cooperation with space, and the other way around. Because sometimes they cover, the today's service operators, 98%. You think it's enough? No, it's not at all. The connectivity sector, covering cable, fiber optics, MNOs, IoT, and satellite providers, is experiencing convergence driven by internet-based technologies. Users now seamlessly connect without always knowing the source. Providers are enhancing market positions through seamless access across diverse networks. Distinctions between fixed satellite and mobile satellite services are blurring, prompting regulatory reconsiderations. As always, we see a new distribution of profit pools within the connectivity players later on. Now, how does this all play together and where does it lead to? In summary, we have discovered 4 consecutive transition eras in the automotive industry, culminating in a new ecosystem that may be dominated by China and the US in the end, and that's the risk. The industry is moving from a product-centric approach to a service-oriented model, emphasizing connectivity, data exchange, and collaboration across ecosystems. The EU car industry is struggling to shift its mindset from the fuel era to emerging software connectivity era. In the past, the focus was on vehicle sales, maintenance, and spare parts revenue as the biggest profit bringer. Now, the industry is at the threshold of what we have called the SATCOM era, although it just displays a very small technology in the whole ecosystem to build, to provoke, we choose this name to provoke the understanding that 98% is not enough, and highlight the importance of the shift from product sales to service contracts. Looking ahead, the Internet of Things era will witness fully automated vehicles integrating with smart ecosystems. The emphasis is on connectivity, data exchange, and the transition to a new era of software-defined vehicles. It's all about collaboration now within an ecosystem of independent players, which is not yet at the heart of the industry. Notably, space technology, particular satellite capabilities could play a crucial role in shaping the industry, extending beyond existing use cases. And, ladies and gentlemen, it's about big business. This study has explored the intersection between space technology and the automotive industry, pinpointing in the beginning 64 use cases in the value chain of the car industry. We now have then prioritized use cases based on availability and accessibility, and this could yield up to 255 billion euro business in the European automotive value chain. Furthermore, this could result in a second-order impact on related industries of the whole ecosystem of energy, smart cities, infrastructure, entertainment, and so forth. The driver is seamlessly connected, approaching more than 924 billion euro. So, what we have done, we have first identified 64 use cases that are all about the digital future of a software-defined car within its value chain that we have segregated into 8 layers. 39 use cases in the automotive industry, spanning all 8 layers of the value chain, are sometimes slightly and sometimes fundamentally depending on the capabilities of space. The analysis focuses on economic impact, considering factors like efficiency, risk mitigation, brand value, potential revenue increase, cost decrease, and so forth. The study also examines impacts on consumers, city governments, and insurance companies. The largest contribution within the almost 1 trillion euro is from the vehicle and fleet data control layer. Notable use cases like autopilot and teleoperation are expected to allow consumers to utilize their time more productively, leading to substantial economic benefits. Also, in the environment side, efficient resource use in the value chain cuts costs and in the same time improves the environment. Space applications like Earth observation and PNT offer ways for the automotive industry to reduce CO2 emission. Vehicle-centric apps such as autopilot and platooning can also lower driving-related emissions. Estimates suggest in our study that 5 to 10% decrease in road emissions from passenger cars due to space-based services will come. Overall, these measures could lead to a conservative 6 to 12% emission reduction, saving at least 40 to 80 million tons of CO2 annually in Europe. The car industry should collaborate with the software, data, space, connectivity ecosystem. Similar, however, the space industry needs to cooperate across its disciplines with its own. The study assigns economic value to SATCOM, to PNT and Earth observation, emphasizing their collaborative impact on interdisciplinary use cases. Traditionally, these disciplines are separated in research and development. For instance, modularity and real-time traffic control benefit from combining Earth observation, PNT, and SATCOM. That is helpful for precise mapping, route calculation, and communication. The analysis highlights the importance of collaboration to fully unlock the economic value potential in the automotive industry. As a next step, we now have put together a database of 137 space technology providers with offerings that are relevant to the automotive industry, categorized into Earth observation, SATCOM, and PNT, including legal entity type, business profile, applied technologies, and funding details. More than half of these organizations are strategically dedicated to serving the automotive and mobility ecosystem, and for those it might be of interest delving in our study or what is in for them. We have developed a clustering approach, the so-called Einstein grid, to match space companies with the specific use cases in the automotive industry. The result is a matrix of 137 space-enabled space companies matched to 64 use cases, providing insights into the space-enabled automotive ecosystem. The matrix provides a multidimensional overview of the prioritized use cases, considering their validity, availability, and implementation timeframes. Obviously, many of the 137 space technology providers initially developed their services for purposes fully unrelated to the car industry, ranging from infrastructure monitoring to precision farming and maritime solutions. These companies face substantial business potential toward automotive applications. We firmly believe in the adaptive nature of space startups, as soon the automotive business model and use case owners in the car industry in charge give guidance. In this context, the study underscores the crucial role of an application layer in integrating space solutions on the one hand into the automotive value chain on the other hand. This layer involves software integration providers embedding space-enabled information systems into business process. Players like SAP, part of this study here, are required in making these services in space available to create value within the product cycle, the production cycle, and the user cycle of the car industry. The study points out that despite the extensive technological developments in the space sector, many decision makers in the car industry remain totally unaware. This highlights a potential gap in knowledge dissemination between the space industry and potential adopters, potentially hindering the broader utilization of space capabilities in the car industry. As we see a fundamental innovation potential making up for the existing gap, we see a great opportunity for the car industry and the space industry in search of business. And actually, it's time to act now. Why now? From the car industry perspective, we have created 3 scenarios for the EU space and car industry: a best case, a worst case, and a base case. I'm now focusing on the base case. Only, as shown in this chart, is a fragmented union which will prevail. In our base case, the EU emphasizes national and industry interests over collaboration, leading to a very cautious approach, hindering cohesive action and compromising global competitiveness. We observe this everywhere in Europe these days. Key features include delays in decision-making and external pressures from digital-savvy new players. Chinese and new US automotive brands will become dominant, with big tech leading the software-defined car market. European influence is limited to hardware and design, and offshore R&D poses challenges to the EU. Even this base case requires immediate concerted action for global competitiveness and sustainability. But what to do? Let me finish with a recommendation. In our view, the European automotive and space sector possesses the necessary strength for competition, yet collaboration is essential for constructing a comprehensive European mobility ecosystem enabled by space. Key factors supporting our competitive edge include: the space industry must recognize its potential within the automotive value chain, identify your specific use case, and initiate engagement with OEMs. OEMs, on the other side, should broaden their focus beyond just car features to encompass the Level 4 ecosystem now. Identify key collaborators and seek solutions collaboratively. While 5G AA, antennas, and SATCOM represents a very good starting point, engage with space startups specializing in Earth observation and PNT with SAT constellations, and explore solutions that position you as a competitor against the Chinese counterparts. OEMs should not only invest in incremental product innovation at this juncture, but allocate venture capital investments to foster the development of its ecosystem, establishing the necessary framework to construct a level 4 infrastructure. We obviously at Einstein will serve as an intelligent platform. Let me finish with my final words. After 9 months of extensive research, there is one thing left to say here. We are in an exciting situation full of change. I would like to thank ESA and the Commercialization Gateway for their trust, for giving us the possibility to demonstrate such opportunities in space and automotive industry. It shows, once again, Europe is full of ideas, but it needs courage and assertiveness and an enormous will to overcome. Then we will turn the challenges today into one of the greatest business opportunities for Europe. Finally, I would like to thank my team who have worked with tireless dedication and commitment far beyond what was required, and our advisors, Porsche Consulting and Akito Flux, have worked outside the actual commercial interests and provided us with crucial insights. Our industry partners SAP, Ergo and OHB spared no effort, and we have gained a unique insight into the symbiosis between the automotive and space industry. The study comprises 190 pages approximately, is soon after approval from ESA ready for download on our website, and I will be very happy to receive your feedback and questions and whatever you have. Thank you for listening.
So good morning, everybody, and now we are continuing with, let's say, let's say in the following 20 minutes you will hear how the automotive sector is addressed in several parts of ESA. That's why it's myself and Elizabeth, and let's have a look to the next one. Okay, so first of all, what I would like to say here is that space is important in the automotive sector, and what you see here are several use cases. So some example of the use case where space plays an important role. For example, satellite communication, ensuring communication network, ubiquitous communication network robustness, resilience, is essential in all the use cases with the connected autonomous driving, but it's also important to see the convergence between satellite communication and terrestrial network, 5G, 6G, to provide the connectivity, which is an important requirement for the automotive, for the stakeholder in the automotive sector. And as we will hear, satellite navigation providing accurate positioning for vehicle tracing and tracking, for guiding to the point of interest, to the location, to geolocalize, for, let's say, time fencing, geofencing feature, and also for accurate position navigation in time and place is also essential in some of these use cases. And then, not least, of course, Earth observation. Let's think about the images that are essential to create the high-definition maps which are important requirements for the autonomous driving, in addition to provide data and information for the monitoring and forecast of the air quality, which is important for the decarbonization of the transport sector. But I would like also to mention, you see on the upstream sector, is also important to mention the future EU constellation, the IRIS2, which stands for Infrastructure Resilience, for Resilience, Interconnectivity, Security, which aims to provide a secure communication and, let's say, internet everywhere, and as such is very important, as we hear, for the stakeholder in the automotive sector. So one of the principles, as we have heard from our director in the program, is to promote the use of space by establishing cooperation and partnership with actors in the non-space sector. And you see here some of those which plays a role in the automotive sector is private, is a government, institution, accelerator, city. With some of them we have already in place a partnership signed, with the other one we are in a discussion. And what is important here is the fact that talking with them, we are able to identify what are the needs, what are the challenges, which then allow us to, let's say, to promote initiative, to put in contact the industry, with the stakeholder, which then use the service and help to scale up the service. Sorry. Okay, so by talking with the stakeholder, of course, we can identify trends, and what you see here are, let's say, some of the trends where space plays an important role. We have put just a few of them. For example, just the mobility as a service is ongoing since several years. But let's say still we know that we can do much more for services, for sustainable service, connectivity and automation. Important also is the trend on the decarbonization, which of course with the uptake of the electrical vehicle, autonomous car, and let's say the micromobility is also a trend due to this transformation ongoing in the city for this human power transportation and for example the last mile delivery. We are also we want to see also the full supply chain where the last mile delivery is covering the last part. In the middle you see the enables, so you see satellite, the space, and then some example of digital technology, so artificial intelligence, IoT, and blockchain. On the other side, you see some of the activity that we are going in the program. Some of them are already on the making. For other, we are, let's say, working on that, just to focus, for example, on, let's say, more efficient transport management system, or, let's say, uptake electric vehicle, share on-demand mobility, and of course, autonomous vehicle, electric vehicle, and so on. And now I will, let's say, just talk with you about some of our success stories, so projects which have been, let's say, successful from many points of view, starting with Human Switch. Human Switch is a service basically to promote the uptake of the electric vehicle by providing two applications, with one help the driver, let's say, to select, let's say, in the choice what is the best electric vehicle, considering the driver behavior, what he's doing, the job, the temperament, whereas in the other one, the application supports the driver already of electric vehicle to participate in this vehicle-to-grid marketplace mechanism. And this is is a service which is commercialized by the joint venture, which has been created by partner of the consortium, successful not only economically, but also socially, because it has created job in more than 20 in the UK. And then the other one, of course, is Darwin. Darwin is also a service that is based on a technology, on an hybrid user terminal, which is able to, let's say, to collect and send the telematic data from the vehicles through a terrestrial network. If this is available, in this case is Virgin Media O2, Telefonica, or via satellite, in case that the mobile operator is not, mobile terrestrial network is not available. In this case is Hispasat. And let's say, in addition to, let's say, to develop a further, let's say, enhance the autonomous software by which, let's say, the vehicle can learn the route and also improve the driving. What you see here is the Darwin shuttle currently running in the Harwell campus in UK, but also extended to Oxford and also abroad from UK in Spain. And you will hear more from, let's say, representative of Darwin. The other two that I'm presenting to you is, the first one is the urban traffic management air quality. So this is a service that has integrated in the traffic management system all the forecast for the air quality, allowing the traffic control manager to take informed decision on, for example, when to close a certain part of the city or route, or change the speed of the light. So basically, rather than tackling the two aspect of efficiency, the flow of the traffic and let's say the air quality, the service has combined in only one service, which is actually currently operational in the city, in the traffic control center of the city of Leicester, and the pilot in London and Dubai. Finally, the other project to present to you is a tandem, which is tackling a different aspect. So the need of the people that they are in remote location, that cannot have an access to the transport, to several transport options. And the service consists, developed by this small startup, is consisted in partnering with the taxi, local bus, in order to create a kind of taxi-like for, let's say, the people. And this has been very successful. Already during the pilot, more than 20 local companies joined the tandem. And as you see, there are many places in the UK where, let's say, the tandem is currently running. And, oops. And this is actually the last, it's a kind of roadmap. This is to give you the message that actually we were in the program looking and active in the automotive sector since many years. We started with the autonomous road transport, where we were looking to fleet management, platooning, and so on. I would like to point out the call that we did in 2020, because it was done jointly with the digital department in the UK, where solutions were provided showcasing the importance of the convergence between satellite communication and terrestrial network. The call on satellite connectivity for autonomous land vehicle safety, where, let's say, we obtain, let's say, proposal responding to user cases that were provided by BMW through a 5G AA. And then, let's say, the last one running this year is the sustainable micromobility. And on the short term, the last two are actually now in preparation. One is the last mile delivery, so tackling the last part of the delivery, so how to optimize let's say, route and so on, and the electromobility running then next year, where the full supply chain of the electromobility will be tackled from the development to operation. And now I pass to my colleague.
Thank you, Roberta. You can say. Hello, my name is Elizabeth Leah English, and I'm from the NAVIS, from the NAVIS team. So NAVIS is the Navigation Innovation Support Program, and we develop the PNT landscape. So let me give you the context of this in the multi-layer PNT architecture that you can see here in the image at the top. So the signals in space, terrestrial signals, and the sensors within the car will, in future, work together seamlessly to support connectivity, which is needed for the automotive systems. So NAVISP is in the Directorate of Navigation, which developed Galileo, most accurate sat-nav system, EGNOS, the SBAS, ensuring safety of life, and a new program, the LEO PNT, which will complement the existing GNSS. So the objective of NAVISP is to build upon these developments of Galileo and EGNOS, and our program is very much focused on the technology development and maintaining competitiveness for industry. So we have very strong engagement with our stakeholders to understand industry needs developing this PNT ecosystem, and we generate return on investment for our participants. And so NAVISP is an end-to-end program supporting from the technology R&D development, supporting industry in their pre-commercialization products and services, and also working with member states to support their national initiatives. And we work closely with industry to support PNT champions and market owners in Europe. So I'd like to say a bit about our PNT concepts. And these key concepts were identified at our NAVISP Industry Days, which we had a few weeks ago here. So you can see more on our website about that. So safety is a key consideration, obviously, for automotive, as these infrastructures depend heavily on PNT technologies. Also, PNT resilience to protect against jamming and spoofing, and jamming and spoofing of radio frequency signals. Standards and regulation, very important, as they're influenced by what PNT can achieve, and this can be a driver to open up new market opportunities for industry. The increasingly accurate PNT solutions will drive efficiency and performance for users. And finally, ubiquitous PNT is still a challenge, as these autonomous vehicles will require 10 centimeters absolute positioning. And this is going to need the integration of many technologies, as we heard earlier, to support this sustainable PNT ecosystem. So NAVISP is working with ERTICO, who are here today. And we had a thematic window, which is a call that we issue to focus industry's proposals on autonomous vehicles. So our call was PNT for connected, cooperative, and automated mobility. And we identified these 5 use cases in collaboration with our stakeholders and ERTICO. And the most proposals that we received were for the ubiquitous and high-performance PNT, and for testing. And this tells us that this is where we need to focus our attentions for CCAM applications to support automotive. I'd like to talk to you about a couple of example projects that we have in NAVISP at the moment. So the first is on technology development for automotive, the supercorrelator activity with Focal Point, a UK company, and they're developing software-defined GNSS receivers for in-vehicle. And these exploit the angle of arrival of GNSS signals, but no additional hardware is required. So there's no need for the high-cost antennas, and can just do all of this in software processing. And this is really demonstrating game-changing accuracy improvements for chipset providers. The second example is the PNT Center for Automated Road Transport in Italy. And this is a testbed for validation in automotive. And this will provide, so it will give you a safety and performance evaluation for PNT, and particularly in complex scenarios that are difficult to model. And there will be a virtual aspect as well as hardware in the loop testing, connectivity with external laboratories, and there's also targeting this use case of smart roads. And this is in line with the several initiatives from the national Italian delegation. The testbed was one of the calls that we had with ERTICO. And so we have this memorandum of intent with ERTICO since 2022 to really develop this connections of intelligent road systems and services. And Navis participated in the ITS Congress in Lisbon earlier this year, and we are working to enlarge the non-space footprint of ESA in automotive. So, in addition, so let me say a little bit now about the Connectivity and Secure Communications Directorate on behalf of Teodora, who have worked with the 5G AA, a global association of car makers. And this cooperation was initiated in 2021, and they have also a memorandum of understanding. And there is a working group which ESA contributes to define the requirements. And a key finding is that no connectivity is not an option. So really highlighting this need to work together for connectivity to provide both terrestrial and non-terrestrial networks. And ESA is working with key stakeholders and service providers, particularly SATCOM providers, mobile network operators, and these all need to work together to ensure this seamless connectivity with 5G and terrestrial and non-terrestrial networks. And ESA is working to shape the market and trigger investment into these areas of connectivity. So this is the 5G AA ESA partnership, and the working group that is led by BMW. And so ESA is contributing expertise here and working to define the roadmap and the requirements of industry, and to support the initiatives towards terrestrial and non-terrestrial connectivity going forwards. So there are several upcoming calls in the Communications and Secure Connectivity Directorate, and in particular this is via the 5G, 6G strategic program, and this is across all components of the value chain, from ground segment, space segment, and systems development. And I also am speaking on behalf of the Earth Observation, and Pierre is here if you would like to hear more. And so there is a tender open with the Global Development Assistance Programme in the Earth Observation Directorate. And this is working with the World Bank and the Asian Development Bank and this has just started recently, so we'll see more developments further on in the future. but is working to assess mobility patterns and traffic imaging. And so we look forward to seeing these results in future. And so finally, what's next for, I'll say for Navist, we have some invitations to tender open, and we also have permanent calls open on our website, and Roberta has mentioned.
Yeah, so basically this there are 4 calls that are in preparation. One of them is, it's already, they can't. So is, let's say, the infrastructure for transport, which is basically tackling what are innovative solutions for the infrastructure in the transport sector. Then I mentioned before the last mile delivery will come next year, where we will look at solution tackling the last part of the delivery, optimization of route and so on. The electric mobility, with all the supply chain of the electromobility, so development and operation. And then also the robotics, where we will look at solution robotics and their impact on the automotive sector. Thank you.
Thank you very much.
Us?
I give now the floor to Christopher Keys, who will be moderating the next round table. Welcome, and thank you very much.
Thank you, and can I ask my panelists kindly to the stage, please? Everybody who's in the room attending the panel, please join me on stage. Good to see you. Wir haben uns schon getroffen. We already met. Hallo. Christoph Käse. Hello. Christoph Käse. So, I go to the very side. Welcome, everybody. We have, I believe, a very strong panel from 2 industries. There's a bit of an echo here. From 2 industries, which is space and automotive. And as we have heard with Uli's presentation earlier, there's a lot to be won in bringing these 2 industries together, combining competencies, and discussing how Europe could take. Should I take the other mic? How Europe could take a lead in getting a step forward with the software-defined vehicles. So let me introduce to you the panel in different order. It's Thorsten Welter of SAP. Where is he? Thorsten. He is the global head of aerospace and defense. Then we have Lutz Bertling, known to everybody probably in the room, Chief Digital Officer of OHB from Bremen. Then we have Johannes Springer, Deutsche Telekom, Directeur General for. Am I doing something wrong, or is it okay? Then we have Georg Heinecke, Porsche Consulting, Senior Manager and co-author of the Race to Space that we've heard about. Then we have Jean-Marc Boucheret, there you are, of Iveco. You are responsible for sustainability and managing your efforts there. Then we have Gero Korman of VW Group, head of Big Tech. And then we have Nicolas Sampieris, I hope I pronounced it correctly, it's okay, of Ertico ITS in Europe, bringing together these industries. And the way we want to do this is we want to have initial statements from everybody. I might start with you. How can Europe proceed in combining the space industry and the car industry? What is to be won and what should be done? Should you start? Please.
Good morning, everybody. So maybe the mic is not on yet. Yes? No? You hear me? All right.
Not really.
You hear me now? Okay, excellent. So on behalf of Iveco, we are here as a bus manufacturer, and we are experiencing two major trends I would like to share. One is on the, yes?
Now we go.
That was an easy one. So Iveco, we are manufacturers of buses and coaches, and we are experiencing a transition in the business, which is first the transition to electromobility, and the second one is also the drivers. On these two aspects, I would say that on the change to electromobility, our buses are operating very intensively, up to 24 hours, 7 days a week. So it means that we've got few time to recharge. We've got to be very precise, and this is where the connected vehicles are very important. Our connecting system called Iveco On is enabling to both know the usage, the power consumption, and to determine when the vehicle will be recharged and how much time he needs for that, so that the operation is guaranteed. And the second aspect of the telematics is also to be very smart on the way to predictive maintenance, and that's also related to the fleet availability. The second part is the drivers, and we know there is a big lack of drivers.
How many drivers are lacking in Europe, missing?
Several tens of thousands are lacking for both trucks and buses, and due to the fact, you know, that we want to get cars out of the cities with the low emission zones and the limited traffic zones, it means that the uptake of public transport is supposed to come, but there are not enough drivers. So it means that we are also investigating for automated driver buses, or driverless buses, which is obviously requiring a lot of data exchange and connections to precise positioning in its environment. So here again, we have developed different proof of concepts, and but we are not there yet. So I would say that for us, main takeaways are, for the end of this decade, would be autonomous buses, large-scale buses, not small shuttles, and more connectivity for the electromobility and for the predictive maintenance.
So Mark, you said something very interesting, just in half of a sentence, end of the decade, which is just 6 years away, actually. When you look at autonomous driving today, like in San Francisco, Waymo is doing pretty well, but Cruise is withdrawing now from the San Francisco market because the license has been collected. So are we looking within the next 10 years, next 6 years, are we really looking at autonomous buses driving in inner cities, fully autonomous?
Yes, but none of the KPIs are correct today. KPIs in terms of supplier base that are dedicated to a heavy-duty vehicle, not a shuttle. We are talking about vehicles that can be 30 ton with 150 passengers on board. So this is a totally different OEM supplier point of view that we have to address. And obviously, the liability is supposed to be on our shoulders. So this is not solving the economics yet. Business model, technology, liabilities. There's a whole lot of effort to be made to reach this point.
Thank you. We continue with Aaron. Please pass on the mic. Go ahead.
Yeah, thanks first of all for the invitation. I'm responsible for 5G Automotive at Deutsche Telekom, and also representing Deutsche Telekom and 5G Automotive Association, which is a global association at the end combining two different sectors, the telecommunication sector and the automotive sector. So all the big car manufacturers are in that association, from a private car industry, so VW and Ford, General Motors, Nissan, SAIC and so on, so also Chinese. It's really a global association because the automotive is a global market. So what do we need to do, and that was your question with respect to Europe and space and automotive. If we take the 3 pillars, what Ulrich has mentioned in his introductory speech, we have PNT from space. I think it's solved. Yeah? We have Galileo, we have improvements, we have a Navis program and so on. So Europe is on a very good way in terms of creating an infrastructure for PNT, which is of course very important for automotive. Earth observation, I think we are also very good, and we have a very good track record also here in Europe to provide data coming from space, whether it's weather or whether it's traffic situation, roads, congestion and all these kind of things, and here is Europe on a very good way. Where do we suffer? And that is satellite communication. We have the US, which are creating own operational infrastructures for satellite communications, relying on 3GPP, 5G standards, and in the upcoming future then also 6G, which are creating an own US-based infrastructure for communication direct to satellite, which can be used also, of course, by the car industry. The same in China. China will do this definitely, and they will set up an own constellation. And we need to have a similar satellite communication also here in Europe, which is able to provide a satellite communication infrastructure for the car industry, which can be used in conjunction and in combination with the already existing terrestrial communication infrastructure for the variety of the different use cases which were already mentioned.
Johannes, can I ask two short questions? First of all, do you consider space communication as a competitor? Because you're a terrestrial company, you don't run, as far as I know, space constellations, so any satellite flying could be taking away business from terrestrial. Are they competitors?
No. Definitely no competitors, because, you know, and that was already said, if we want to get the benefits from all these kind of use cases, connected car use cases, it is clear that these use cases are more and more mission critical and they need 100% coverage. Is it economically wise to provide 100% coverage by terrestrial? No. So from a telecommunications perspective, it is very easy. There are, of course, a lot of locations where it is easier and more cost affordable to provide connectivity via a satellite communication structure.
Makes a lot of sense.
And also from an operational perspective, you know, also Deutsche Telekom, we are not providing our networks everywhere around the globe. It is already today a partner business. So if you are jumping out of your plane in China, you get connectivity with hopefully a Deutsche Telekom SIM card. And does this SIM card works in the Deutsche Telekom network? No. But it works in a network where we have partner agreements with, whether it's coming from China Mobile, China Unicom, or China Telecom.
Get the point. Second short question. Look at Jeff Bezos. He had a job on Wall Street. He quit the job on Wall Street and opened a bookstore. Today, this bookstore, as we all know, is the biggest retail company in the world. It's also the biggest cloud provider in the world, and now he's putting up a satellite constellation. So he was totally unlikely to come up with these businesses. So what is it about European entrepreneurial spirit that we have not put up the constellation, the communication network that you're talking about? What is wrong here? Why has nobody stepped forward?
In Europe, we have, of course, one very big opportunity on the one hand side, but also one very big challenge on the other, and that is a big fragmentation of the market. If you are able to set up a satellite communication constellation in the US, you easily get access to 300, 400 million customers in one country with one more or less legally harmonized system. In Europe, you have 27 member states with different spectrum regulation, different regulations in terms of terrestrial, already existing terrestrial networks, and that's always the big challenge we are facing in Europe.
Thank you very much. Could you pass the mic to Lutz, please? Lutz, this must be like music in your ears. Everybody's calling for
of course it is a bit.
Satellite constellation, and you're building satellites. Isn't that great times for you?
By the way, not only, we are doing downstream as well. Yeah, I think what I want to say is a bit complementary to the remarks we just heard. I really believe it's complementary. Terrestrial and space is complementary. And you would see this in my, I would say, 4 decisive factors for this. No connectivity is not an option, how to achieve it. And it starts with very simple things, and we are very thankful for that 5G AA exists. It starts with a little thing which is called standardization. We need to make sure that Europe, or even better, Europe and US, and the best global, Europe, US, Asia, is coming up with aligned standards, because otherwise de facto standards will be created, but it will not be one standard, it will be many standards. And if we look at the increasing success which the Chinese have with export and car production, we have seen that 1/3 of the global car production is in the meantime in China. Their export becomes stronger and stronger, in particular with electric vehicles. They might set the de facto standard if there's not a global standard. So we are very central as a first factor to that these global standards are in development, hopefully at least. The second factor for me is a very simple one, secure frequency rights. And secure frequency rights not only in SNL band, which are good for narrowband and good for 2026 and 28, but we will go to broadband and we will need Ka and Ku band. So secure frequency rights is mandatory. If you don't have them, you can dream about satellite connectivity. You will not have the slots to position the satellites for the connectivity. Third factor, and here I'm very much aligned, connectivity always and everywhere will need hybrid solutions. Resilient and redundant connectivity is what you need, or what we will all need, and this needs a fusion of terrestrial and space-based infrastructure and services. And wherever terrestrial is available and good enough, likely you go for it simply because it's cheaper. But it will need the hybrid solution. The space component needs to have global coverage, including all Europe, which Kuiper doesn't have. It needs to provide a guaranteed service, which Starlink doesn't do. So the European sovereign solution, IRIS², from my point of view, is mandatory and not as an institutional thing, only as a private-public partnership, not to mention other factors like the European Data Security Act or security-related services in Europe. My fourth point is seamless connectivity in hybrid solutions. And we have seen one example already in the speech before. Seamless switching between the terrestrial and the space services without any service interruption is a must. And here we strongly believe in the solution provided by Unio, which is a Munich-based startup in which we, alongside with IABG and with SES, we recently invested. We strongly believe that such solutions are a mandatory service, that the user and the systems using these connectivity services, they should not even notice if they just switch from terrestrial to space or back. These are for me the main four factors. Perhaps let me mention in one sentence one more. 24/7 spectrum monitoring is mandatory, and therefore we are very thankful as well for the ESA ITU initiative, Clean Wave. Thank you.
Thank you. One follow-up question to you, Lutz. You just mentioned very quickly a technical difference between IRIS² and Starlink. What would be, concerning the car industry, what would be the advantages that IRIS² would have for the car industry as opposed to Starlink? In more detail.
First of all, it's a guaranteed service. I mean, Starlink has this tiny little disadvantage that one private man can decide that in a certain area of the world he doesn't provide a service, and he did already if he doesn't like something somewhere. So for always available connectivity, you need definitely a guaranteed service. Secondly, it's a multi-layer constellation. It's a constellation consisting out of low LEO, high LEO, and MEO services. With a MEO service with a few satellites, you can very fast get a global coverage. On the other hand, you have some latency issues. If you need cloud computing, we discussed this in a smaller circle earlier this morning. If you need cloud computing, this latency might play a certain role. If you have computing power on the satellite, then less, and so on. So you have a choice of different LEO and a MEO solution. You have a multi-layer solution, and you have sovereignty. You have simply European sovereignty, which is not neglectable.
Okay, last question to you. How much of the computing power will be shifted up to the satellites because it's more economical to have it in the satellite rather than in the bus or in the car?
Yeah, I believe we all don't imagine what will happen. I mean, look at our little small smartphone and compare it with the computer which we had on the Apollo spaceships. It's much more powerful than what has been on the Apollo. So from today's point of view, I would still say computing power in satellites will be limited, and most of the computing power will sit on ground for many reasons. Particular latency is not always that important. There's only certain applications. There you can go through LEO and you have low latency. But computing power per weight, per money, per whatever you take, space you need, is improving that much over decades. I don't dare to give a real answer for the 2030s. Just by the improvement in computing power, we might see more computing power in future generations of satellites, not in the current ones, but in the future ones, simply because it's so cheap, so small, so less weight that you can afford it.
Thank you very much. Very insightful and very honest, by the way. Nikolaus, please. You are, as a professional, trying to bring these...
Nikos for my friends, yes.
Yes. You're trying to bring these industries together. Is it a fun enterprise, or is it difficult? Do you have to push all the time, or is it a lot of pull?
First of all, thank you very much for your introduction. I'm Nikos Tsampieris. I'm a senior manager in ERTICO ITS Europe in the Innovation and Deployment Department. So a few words about our organization. It's a public-private partnership, and we have more than 120 partners, including various mobility stakeholder communities. And we strive all together for sustainable mobility to reduce the environmental impact of efficient mobility, which means zero delays and fully informed users, and of course safe mobility, aligning with the Vision Zero for zero fatal accidents on roads by 2050. So we deploy innovation there. We are running currently around 30 R&I projects with a budget of over 300 million, and the part realized by the ERTICO partnership is 75 million. So innovation is a key element in our activities, and in all these projects, satellites are also a key element. I would like to expand, but Johannes and Lutz stole my lines. First of all, I want to go back to the matter of competing technologies. These are not competing technologies, they are complementary. It has been shown clearly in one of our projects, to draw an example, 5G Mobix, where we deployed 5G solutions in 7 countries in cross-border corridor environments. And it became really clear that hybrid approach was the best approach to ensure robust and uninterruptible communication. Regarding the PNT infrastructure, I agree with what Johannes mentioned. And what shall we do to bring the communities together? Of course, it's fun. It's fun because innovation matches innovation. I think we should look forward to strengthening cooperations like the ones that we had with ESA, and I want to mention a particular one. I think the colleague from ESA Navisp showed before a slide regarding this. We teamed up with Navisp last year to put forward a thematic window with the title Ubiquitous Communication PNT for SICAM. And I would like to thank here the Rafael Lucas Rodriguez, who is the head of Navisp Technology Program Office. I think somewhere in the audience. Thank you very much, Rafael, for this collaboration. I think this generated great interest, attracted a number of good proposals, and I'm sure a lot of innovation will happen there, in particular introducing, for example, PNT solutions and technologies in the automotive sector, which leads to another point I would like to make, that we have to strengthen our effort to really put all these technologies and concepts into real commercial products.
And in order to do this, there should be frameworks, right? What's your call on frameworks? Because one of the topics we want to discuss today is what hurdles are standing in the way and how could we overcome the hurdles. So could you elaborate on the framework, please?
First of all, I think there is a major hurdle, an obstacle for the collaboration between the two sectors. These are the development cycles. For example, the automotive has short development cycles, yeah? While in the space segment has longer development cycles. So these two, let's say, approaches have to be aligned in order to progress and move forward. Another issue is risk. Let's face it, automotive industry is risk averse. They follow well-established procedures, developing the products, while space sector, let's say, has more fun in taking risks, recognize that it's part of the learning process, yeah? So again, there's a discrepancy there, and I think it's a hurdle, it's a major barrier, let's say, regarding the alignment of the two sectors.
Can be willing to accept risk. Could you please pass the mic on to Thorsten? Thorsten, SAP, everybody's your customer. Everybody's running on SAP. You have also transformed your own company towards cloud, and cloud is also very dependent these days, or will at least be in the future, on space communication. So your take on the collaboration between car industry and the space industry.
Yeah, good morning, and thank you for having me. I'm Thorsten Walti with SAP. Absolutely, the industry itself, industries, all of them, in particular, the software industry is really moving into a new tact speed by moving into the cloud, because the innovation cycles are getting really shorter. So the only way to get to distribute the new innovations is by having an infrastructure that's accessible for all, and you can distribute the information or the new technologies in an agile way, in a cost-effective way. This is not just for SAP cost-effective, but also for the customers. Especially if we go towards AI, it's critical that you deploy the new innovations really quickly. What does it mean for this particular area? We see new trends. Our customers, especially, we wish everybody would use SAP, but a majority of the companies use SAP. But our customers really look at SAP to look into their operations, to get insights, to measure their operations, improve it, and then also reduce risks, right? Those are the key things that the CEOs and the COOs are really looking after and looking for us from SAP to provide. What does that mean in this context for the automotive industry? Over the last couple of years, automotive industry really scaled up in manufacturing. Now they're moving into more a shared economy. We see it from the economy, the user perspective. They're going more into, I want to share a ride. I don't want to buy a car anymore. I may not have the money in the future to buy a car, or it may be really hard, or I have to do something differently from an ESG perspective. So there will be new trends coming up, and that means that boundaries are breaking down. Boundaries between industries. That means a car manufacturer is not just a manufacturer anymore, they're a service provider. That means they're completely different. So therefore, this will really drive a new, different way for the companies to look at the areas, especially if they go into new areas. They need to manage the risk and the resources more efficiently. And that's where it comes, where the external data is really, really critical. Satellite data is, in particular, one of the key components that they can use to provide new services, make better decisions on the future of their operations. That's, in essence, one of the key messages. To take away, the companies need to collaborate more because silos break down. Companies need to be open to adopt new technologies because the speed is way higher, especially from the competition. And governments need to look at it to put infrastructure in place so the companies and the consumers can take advantage of those things.
Can I ask you, you representing a software company, and we're all talking about software-defined vehicles, European car industry has adopted in some way, but not maybe as quickly as others. When you look at, of course, Tesla, but also Beyond Your Dreams, these are cars built around software, not the other way around. How are you foreseeing the future as a software company? Are the European car makers finally picking up speed in producing good software? Because as I understand, software is absolutely necessary to make any purposeful use of space technology.
It goes back to collaboration. If you look at it, the difference between the cars that are out there, like the Teslas or some of the Chinese cars, they build the core center as a software-driven piece. They have a platform that coordinates with all the components around it. If you look at today's dynamics in the European or established car manufacturers, they have a lot of components, and each of the components have their own intelligence, their own platform. To integrate that into one area requires that a lot of boundaries break down, that a lot of sharing, collaboration happens. From a software perspective, it also requires a completely different dialogue in regards to software distribution, right? If you have one center area where you manage everything from it versus 50 different thinking areas, it requires a different infrastructure to do so. The positive piece in it is recently the European, in particular, OEMs came together and also tier ones to really establish Catena X as a collaboration platform to really address the supply chain issues and the ESG issues that are common to reduce decarbonization. So there is a great effort that the companies come together, but I think from a question that you posted earlier to the fellow panelists, I think there's still a lot of boundaries that a lot of companies do things on their own versus come together and saying we have to get to a much better place to collaborate and improve the innovation cycles.
Thank you. Could you pass the mic to Georg? Now, Georg, you get the toughest question on the entire round because you're the consultant, you need to know the answer, right? So in these very complicated, very competitive circumstances where the rest of the world is moving very quickly, as we've heard before, what should European industry, both space and car technology, do to better collaborate, to push, to get out vehicles faster that are software defined? So what's your silver bullet on that one?
Okay. As any good consultancy answer would be, it depends. So first maybe from my side, Georg Heinecke. I lead the space practice for Porsche Consulting, and as any good consultancy company, as you mentioned, when we come in, usually it's like the wake-up call for the company. And we do that basically in two dimensions. The first dimension is in space companies. We often come in for industrialization strategy as well, but obviously, as all of you know, volumes increase significantly in the space industry in terms of launchers, in terms of satellites, so there's a strong need to sort of learn from the automotive industry how do we produce these the hardware efficiently, cost-effective, and so on, so that it doesn't that you don't run out of cash before you actually get to space and can offer a service. So that's the first pillar of our business, and already part of the answer as well there. Second pillar of the business really for us is the wake-up call towards our clients, and obviously as a Porsche Consulting, our biggest client internally is obviously the Volkswagen Group. And so while obviously dealing with space companies, we saw that there's really tremendous disruption ongoing in that industry as well, just as much in the automotive industry, disrupted by electrification, now space disrupted by the likes of SpaceX and obviously also China. So very similar sources of disruption actually. And in the automotive industry, we saw that through this convergence of autonomous driving and connectivity over the next coming years, and we see that by the end of the decade, basically both technologies will somewhat converge to go mainstream. We see that the car will be an extension of your living room or your office space, right? And so when that happens, so when the car is really autonomous, then you actually really need the connectivity 100%. And so we are also for the Volkswagen Group a trend scout internally to monitor the technology, to push the company internally to look at the technology in space and what it means to our business model. Yeah, so these are the two pillars. And now to your question, what needs Europe and the automotive industry to do? From our point of view, obviously, as we've also seen in the keynote, in the automotive industry as well as in space industry, China and the US are pulling ahead, right? So, I mean, the question is not, can we still be first? The question will be, can we still set up now an infrastructure that is, let's say, competitive when the second generation comes along, right? The first generation will most likely be test cases with, you know, the likes of Kuiper or Starlink. But we really need to make sure in Europe that we pull together and that the second generation, we actually have a competitive chance to also have a system that's efficient, cost effective. For automotive, it's always about cost in terms of hardware, that is performant, secure, obviously. And so this is, from our point of view, the most important aspect. And so what needs to happen? So as we do in our business, so one thing is the European space industry has to industrialize, has to push the boundaries, just like the other industries in US and China. And in automotive, very much the same. And looking, in this case, also into the space industry, providing the funding, providing the backing, so that eventually there will be the possibility to have a business case to a certain extent, where automotive is part of the discussions. We can also set the standards, a very important part. So just basically being part of that initiative and being part of taking part in this development will be very important.
Thank you, Georg. And now unfortunately, it's so interesting listening to you. We could spend all day, but we have just 20 minutes or so left. So there are three key issues we want to discuss. First of all, how can we promote collaboration and what would a perfect consortium look like? Second of all, what's the hurdles? So let's put the finger in the wound and say, this is what we need to fix. So let the signal go from out here to the industries. And thirdly, very important, we're guests at ESA today, ESA. So what can ESA do? What is everybody hoping for? What can a multinational, multilateral organization like ESA do to promote what we are talking about? Consortium, can I pass, because 5GAA, Johannes, is listed below your name, right up there, not Deutsche Telekom, so you're professional consortium builder. So what are you hoping for? What would be the ideal combination?
Collaboration needs to be organized, and a consortium like 5GA is exactly a collaboration platform. 120 plus members. It's global because the automotive industry is global, and it brings together all the various players which are relevant for connectivity and automotive, including supplier industry, including chipset industry, including antenna industry, and all these kind of things. So collaboration needs to be organized by platforms. What are the hurdles? What are the hurdles? And I want to stress one point which was said, and that is standardization. Very often, and I can tell this from a personal experience in collaboration with the satellite industry since 20 years, the satellite industry very often has problems with standards. They are creating encapsulated systems, not taking into account that something is already there. So if we are talking about car connectivity, what Ulrich has said in his introductory speech, 98% of the cases, the car is already connected, maybe 95%, maybe in the north of Scotland, only 90%, but the car is already connected. So if I want to organize a system which creates an added value for an industry, I need to integrate this system invention into an already existing ecosystem. And that is based on standards. So in the whole terrestrial world, we have 3GPP standards, we have 5G, we are going into the direction of 6G. And of course, we need to talk also 5G on the satellites. And this is exactly what Starlink will do, or is seeking to do. And the Chinese colleagues are doing the same. So of course, Europe needs to take and to incorporate, and we have big strengths in Europe, to invent these kind of standards, need to rely on these standards. That is an essential must-have.
What can ESA do?
What can ESA do? ESA can organize that the taxpayers' money at the end, we have on one of the slides, only one of the slides, IRIS² mentioned. And IRIS² is taxpayers' money which goes into a satellite communication constellation based in Europe, It's Europe's taxpayers' money. And of course, our expectation, and also thanks through the collaboration with ESA, we want to organize that this taxpayers' money creates also a business value for the telco and for the automotive industry. And of course, by the way, also for other verticals which are suffering from connectivity from time to time.
Jean-Marc, may I ask you on hurdles? What is keeping the industry from collaborating stronger with space?
Again, standards, obviously, but there are also a lot of standards for automotive that gives all OEM a way to develop. We are also in a business where this is also, let me say, public money. It's public transport, passenger transport. It's also taxpayer that is able to develop in Europe. So we also take great care that we have also factories in Europe serving European customers and municipalities. It's important that the value stream is developed also further down to the batteries of gigafactories, for instance. So this is something which is not the case today because all this part of the value stream is coming from China in this moment. So we are able to adapt. We are making our own battery factories, but the precursors naturally should be made in Europe. So this is important that also we take care that some kind of reciprocity in terms of borders between US, Europe and China is, let me say, fair from that perspective.
Thank you. Lutz, what's your take? And what should ESA do? What can ESA do?
Yeah, before coming to ESA, I would like to speak a bit about the collaboration and more looking on the space side. There's many areas where Europe is in the lead. Earth observation, Europe is clearly in the lead. Even geostationary telecom, Europe is in the lead. The majority of geostationary telecom satellites is today coming either from TAS or from Airbus. It's different when we look at telecom constellations. We are in a catch-up situation. We are running behind two others, which is the Americans and the Chinese. And therefore, what is important, and one of the important elements of IRIS² from my point of view, is joining forces. And IRIS² will be realized in a very close cooperation of the three big players, Airbus, TAS and us, of SMEs, of startups. It will be managed in a different way. New space is nothing which is a privilege of startups. It's a different way to run space projects, much faster, much more agility, much more risk-taking and so on, which we will need here to manage the catch-up. We need to join forces in Europe in the space industry, all kinds of players, from the tiniest little small startup with 6 people only, up to the big entities, working together with operators, working together with customers. And this private-public partnership will drive the competitive aspect, because if it would be institutional money only, then there's no real pressure of return on investment. The private-public partnership, if everybody works together, still drives competitiveness, because the private money needs a return on investment. The operators will make sure that we are coming up with a competitive solution. So I really believe we are that much behind, sorry to say so, but we are that much behind that we need to join forces in Europe and we need to catch up. ESA's role, very shortly, lots of contribution on the technology side, lots of contribution in terms of bringing partners together, managing 27 member states. They do this very well, and somehow you need to bring this institutional money and desires and everything together as well. It's a job where, honestly, I don't want to change job with the ESA guys, and ladies, by the way, but I think this is a strong contribution they can bring.
We just got 1 minute left. Thorsten, you want to add to that, or?
Yeah, I think if you look back at the kickoff of Catena X, that's when happened when the CEOs of OEMs and Tier 1s came together and really tackled around very specific issues. I think the inspiration on sea level, especially in Europe, needs to be more fostered. In ESA and the governments around it can basically bring those executives together to showcase.
Was it the government bringing them together, or did they meet?
Yeah. This was a couple of companies get together with the German government and then invited all the other CEOs of the tier ones and OEMs and really set the stage there to discuss how do we tackle supply chain during COVID and also the ESG part. That was kind of facilitated through the German government, but I think ESA can play a similar role in this environment because they have access to all the different governments, plus also with a reputation to the C-suite to really bring that inspiration.
Thank you. Georg is nodding. You agree?
Absolutely, absolutely. From our point of view, I mean, the most important thing will be to keep any consortium to a certain extent lean, because, I mean, as you can see, I mean, here also from this panel, right, I mean, obviously it would be good to have everybody sort of contribute from telecom to Volkswagen to the space industry, obviously, but the bigger the consortium gets, the more cumbersome it will also be to execute the project. So I think really here the space industry needs to go into the lead together with ESA, and I think that there ESA plays a really important role. And then basically try to get the automotive industry into the discussions so that the standards, so the requirements from the car industry can be reflected, but still keep the consortium lean enough that it can still, let's say, execute the project.
Thank you very much. Nikolaus, final words on this?
Yes. First of all, public-private partnership is the way to go, joint initiatives between the sectors. And what I could, and this is the game as well that we are playing in ERTICO, for example, public-private partnership. We've aligned on many occasions with 5GAA partnership, so that's the way to go. And then we should say what ESA does. And my colleagues, my fellow panelists already mentioned, so cross-industry forums, like this one. I mean, you know, that's a great thing to happen, and people come together and discuss and create synergies. Research and development grants has been done. Technology transfer programs has been done. Collaborative innovation hubs, again, they do it. But one point that I would like also to mention is the industry standards and regulations. Common standards should be developed between the two sectors for the sectors to align and progress further.
Yes. Well, thank you very much. This reminds me of one anecdote, how the Boeing 747 was built. The Pan Am CEO went to the, you're nodding, to the Boeing CEO and said, if you build it, I buy it. And this guy said, if you buy it, I build it. And they came into business, and the rest is history. Thank you very much for joining. Thank you for listening. Have a great day. Thank you.
Thank you very much to all the panelists. Now, the last mile before our lunch break, I will ask you to welcome with a warm applause our startup. There will be 5 pitches from startup in ESA environment. And I would like to remind that to hold the startup that you have 4 minutes sharp. Thank you very much. Please, the first one I think is Harty. Please join the stage for your pitches. Thank you.
Hello. Yeah. Thank you very much for having us. So my name is Konstantin and I'm from RT, and we provide AI solutions for autonomous mobile robots. We are a spin-off from the Technical University of Graz. We're now 15 people, and we have been ESA incubated at the beginning of beginning of this year, and and work internationally. So when you think about autonomous mobile robots, we have different industries we want to work with, and we have divided the technology in 2 major fields. First, you can see on the lower end, basically is the edge device, the robot itself. It needs to understand where it is, where it needs to go, safe navigation. But our startup is also working heavily on the right side, on the environment part. So where does the software live then? which means all the calibration, all the connectivity we are talking right now, but also the deployment. And the deployment is very often very difficult, very complicated, and takes a lot of time. So our target is about improving automation and increasing adaptability as good as we can. Therefore, we provide AI kits, software components with AI-driven models for mapping, for localization, and all you can think of, and you see on the slide. We also provide services across the industry, so we explore first ideas, we improve existing systems and support wherever we can. We also build mock-ups to provide every help the customer basically needs. When you think about navigation in urban environments, it's pretty difficult. Basically, you need to know a lot where you're driving, where you want to go, what are the legal constraints, and everything you can think of. The problem is, how can we teach a robot to do that, basically? When you think about the technology part, we teach the robot by saying, like, that's the predefined, most attractive route. Of course, you don't want to go straight to the goal. You want to have the robot use certain highways, as we call them, navigation areas, where it is safe and legal to drive to, and as fast as possible. The problem is the setup. When you see a setup on a compromised premises, there's a lot of work to do for the engineers. So engineers need to set up the environment by themselves, picking routes and doing that everything by hand. And you can imagine this takes a long time, especially when you work for very large areas, like city areas or urban surroundings. So our approach to get the deployment more easily into the field is about using satellite imagery as deployment matters. We segment the image and then create this roadmap automatically, which is very important. You ask what are the scenarios out there? It's robot as a service. We want to get the robot as quickly as possible to the outside world for package delivery, for transportation, but also for infrastructure, for maintenance you can think of, last but not least also for search and rescue. So it was very quick, but I have only 4 minutes. Thank you for your attention and happy to discuss further options. And I'm here today.
Oh yes, sorry. Good morning. So I think that we are a good example of what Lutz just said from OHB about the role of ESA as a technology provider. In fact, we are a technology that has been developed by ESA within the first company that I start called Euro Heat Pipes that developed this phase change cooling solution in order to cool the electronics that are inside of the satellite and bringing the heat from these electronics to the outer panel of the satellite in order to launch that into deep space. This first company, we sold it to Airbus, but I kept the technology and I incorporated Calios in order to address the problem that all the electronics are ever more having, increasing in power and in thermal dissipation, in small packaging. So on Earth it was easy at the beginning because you have air, and so bringing air to the place where the heat is dissipated was easy. But with this increase of power it's no more possible, so we need another strategy. And this strategy is the one that we use in satellites. So that means taking the heat from the dissipating device and bring that to outside, to another place, to a remote place where you can reach a better cold source. That means outside for the satellite, but also within a car, bringing the heat from dissipating electronics to another place where you can cool it more easily. Furthermore, the solution will be without any pump, without any maintenance, also something built naturally for the space business where everything has to stay 15 years without any maintenance. So for example, we apply that for the advanced driver assistance system, but also for the autonomous driving systems with an important OEM. In order to cool, to break out the limit of the 40 watts and going to 200 watts, even 1000 watts of this autonomous driving, this kind of compute that you have inside of the car. For a technology provider like us, we are a small company, we are 20 people. My first company is now much bigger, but now we're starting up again, and we are discussing directly with the OEMs. So this is a bit the way to work, discussing directly with the OEMs in order to prove the technology in labs, but that's one part. The other part is to go down the line for the market, and so that means to prove the technology in cars and also to bring strategic partners with us in order to develop a solution that the OEMs can be satisfied. So that means large quantities. To do that, we've been supported by ESA on this second part of the trip, going to in-vehicle testing. And so, for example, in this case, we have tested our ADAS solution within a car in the Detroit area in order to test it in all the real example of conditions. This is the first project that we have. And we have another one which is very important also in order to help to cool batteries, to allow those batteries to go to fast charging and also to go to fast discharging, which is something that is less known, but that will be very important for the vehicle to grid possibilities that we can give. So I think this is a very good example of the collaboration between ESA and the industry for providing new technologies. Thank you for listening.
Good morning, everyone. Thank you very much to ESA for inviting Darwin to present here today. It's a great honor. I'm Daniela Petrovic. I'm co-founder of Darwin Innovation Group. I must say we are an innovation ecosystem. We are a combination of startup, industry players, academia, and government. So that's very important to say, and I think the success of Darwin over the last 4 years is the testament to that setup. Darwin was created really to answer the challenge of connectivity. And we've heard the panelists today talking about hybrid communication being the answer. We created a solution for hybrid communication by combining terrestrial and satellite communication in one module. And we tested it in the vehicles. In the areas of no terrestrial connectivity and going in and out of the area of terrestrial connectivity. The reason I think this might not have picked up yet, because we are focusing a lot on technology. but there is a big discrepancy in business case and pricing when it comes to satellite and terrestrial communication. So the price of satellite communication is still prohibitive, very high, and if we create a hybrid communication solution, this very big discrepancy can be overcome. With hybrid user terminal we created and patented, we believe that this is possible, and by implementing this solution in vehicles of any kind, including autonomous vehicles, we can not really do the catch-up with, as we mentioned, US and China, but we can be at the forefront of this game, we believe. In addition to creation of hybrid user terminal, we obviously had to create a back-end integration. So terrestrial operators and satellite operators were combined in one business support system, BSS. And in that way, we create billing, charging, and provisioning for this hybrid communication. So I invite, and this is a great, really, example how ESA is helping this type of innovation, is this type of platforms and meetings where we invite, I would like to invite all automotive players in the audience, terrestrial and satellite communication providers, to try and test our solution, because I believe it's ready for commercialization. We tested the hybrid user terminal and ubiquitous communication in autonomous vehicles, and we operate the longest running trial in the UK, over 3 years now. We run autonomous vehicle with our technology implemented on it. So we run every day from 9 a.m. till 4 p.m. an autonomous vehicle, which can be tested. And over that time, we created created bigger innovation ecosystem than we anticipated, because every day we collect over 1,000 data points from the vehicles, and the insurance industry became very much interested in what we do, and we created the first smart insurance model for insuring ADAS and autonomous vehicles. That is another point really to answer some of the comments in the previous panels, that yes, liability for autonomous vehicles will be moved to manufacturers, but the new insurance models are there to inform us how we can do that. Thank you very much for your attention.
Hello? Yeah. Perfect. So my name is Patrick Henkel. I'm the founder and managing director of ANAVS. It stands for Advanced Navigation Solutions. We are around 10 years old and have nearly 40 people. And we are trying to provide a very fancy system that helps when you develop an autonomous car. Basically, we would like to be the reference system, the ground truth for positioning, for mapping, and for object determination. And this ground truth looks a little big, but let's say it's the ground truth, and it includes a number of sensors in a single platform. More specifically, we have 3 GNSS antennas, 3 because we are also not only making positioning or the 3D attitude determination. Furthermore, an IMU, so to bridge GNSS outages, a high-end camera with 160 frames per second, high-resolution global shutter, and a LiDAR sensor. And of course now, very important, some powerful processors for sensor fusion, for combining the data, for precise positioning, mapping, and object detection. An LTE module for getting correction data. Yeah, and what are the customer benefits of this platform? First of all, as I already said, it's a ground truth for positioning, mapping, and object detection, which you typically need if you drive, for example, in challenging environment. If you have a lot of multipass that affects the GNSS signals, if you leave or enter a tunnel and there's a lot of over or under exposure of the cameras that you cannot trust them, or if you have heavy rainfalls like today outside, and the camera and LiDAR sensors are challenged. So the art is really how to have not only high resolution sensors, that is one important pillar, but also how to make the sensor fusion. Then the system is very easy to install and also to uninstall because it's simply all in a single box. There's no need for individual cabling of each sensor, no need for manual and error-prone determination of the lever arms, so of the relative positions between all the sensors. Yeah, and it provides, as mentioned, position mapping and object data in a single device. One very technical slide, it describes the sensor fusion in a so-called Kalman filter. So this was funded in an ESA project called MUSE, where we are very grateful to have this. So basically this Kalman filter takes in as sensor raw data, here shown on the left, the raw data of the GNSS receivers, IMU raw data, vehicle raw data, and local positioning data. Moreover, some correction data are coming, so it can be RTK corrections or also PPP corrections from the high accuracy service. Also, visual sensors are supported, and there's a functional monitoring at the end. So, to show you that this is really working, we have tested it in a challenging environment, the so-called Mittlerer Ring in Munich, and the ground truth was the Oxford system in blue and white, that is what we are. And we just show it here in a few challenging environments where the car was driving below some areas where there's no GNSS signal reception. Here, for example, a railway track junction. Another one, yeah, here, so-called Leuchtenberg Ring, 200 meters long. And this is one of the longer tunnels in Munich, the so-called P12 ring, 1.5 kilometers, although some turns. And we can have a continuous trajectory without a single jump at the end when you leave the tunnel. And now 2 videos at the end to show you a little on how it works. The overall sensor fusion. I hope you can see it. You see in the let's start in the upper left. View 1, it's just a camera image. The view 2 will come the map being built by the LiDAR sensors. It's coming in submap, so you will see how it will extend from step by step. And in the lower left, you see the GNSS visibility plot. You see the sky plot, the signal strength of the different satellites from all constellations. And you also have this map being built from the sensor fusion. And the particular challenge of this data is that it is a continuous indoor-outdoor transition. Half a minute left. And so the car will drive into an indoor area within, let's say, 10 seconds. And then you will see the satellite visibility will go down. Just 1 or 2 more seconds. But the position trajectory, both in the upper right as well as in the lower one, will continue. And actually it's even quite a lot of features, textures here in this map that are used for positioning. But this platform is not only valuable for positioning, as I already mentioned, it's also the ground truth for object detection. So another video here from a test drive near the Technical University of Munich. You see it's quite challenging environment, many pedestrians, many parking cars, bicycles. Here the classes are identified. Yeah, so I leave it that you have a certain impression on it, because I think my time is close to the end, and I think this is, very valuable if you would like to make your trajectory planning for an autonomous car. You need to know really where all the objects are. Thank you.
Hi, I'm very conscious that I'm stopping you for lunch, so hopefully this will be quick for you. So I'm going to be introducing EV Technologies, which actually is a company that was founded from the back of the Human Switch project that Roberta mentioned earlier. So just a little bit about myself first. My name's Dr. Rebecca Roberts, and I have spent my career helping fleets and organisations to transition to electric. The reason being because when they have done that, there is a huge amount of opportunity in the energy in those vehicle batteries. They are giant battery stores driving around, and that's what my engineering doctorate was about, vehicle to grid. So a little bit about EV8 to begin with. So we provide software solutions that support EV adoption, electricity grid integration, and energy optimization. And we do this using GNSS satellite data, hence the reason I'm here today. And the reason we do this is to help organisations make that transition to electric, how they can then navigate that space of once I've got an electric vehicle, how can I benefit from that? Not just from it being good for the environment, lower total cost of ownership, but also, as I mentioned, that vehicle to grid opportunity. So where this has come from, as you know, electric vehicles are increasing, and that presents a huge opportunity in terms of the environmental implications and those costs, as I mentioned, but also a challenge as energy is decentralizing. We have a lot of renewable energy coming into the mix as well, and that could cause a huge amount of cost to the grid, or as I say, a huge opportunity where we aggregate those vehicles together using something called a virtual power plant to provide energy trading, charging, discharging back to the grid. In fact, it's such a big opportunity that you're talking about roughly 15 billion estimated by 2030, and the potential power available is in the region of 350 gigawatts of projected capacity. But we have a challenge to get to this point, and that is how do we get fleets and consumers into those electric vehicles? Everyone knows that we need to do that, but the question is, such as those on the screen, what about if I don't have enough range in my vehicle? What about if the cost is too high? You know, electric vehicles cost more. All these challenges, and that's why we've identified, actually there's an opportunity here first, before we get to that exciting energy distribution part, in how can we get more people into electric vehicles quicker using digital solutions. And that's where EV8 comes in. So we developed EV8 Switch and EV8 Live, supported by the European Space Agency. And these are digital apps, web apps and mobile apps to help you, first of all, get into that space of, I want an electric vehicle, how can I get there? And then through partnerships such as financing and so on, we get people into those vehicles and then keep them in our ecosystem until they get to the fun bit at the end where we can then start doing energy trading. And we have a number of patents and algorithms in that space on how we predict load at a location based on GPS data from the vehicles that we collect at the beginning of that value chain. So in terms of our current traction, we've deployed that first bit, that EV8 Switch, and we've also got a fleet version as well. And we've worked with a number of organisations, including ESA, actually, should have put that on here. And we've had over 6,000 downloads of that particular app. And in the next 12 months, our goal is to finish developing out that 7-stage end-to-end process so we can then start leveraging the energy from those vehicles that are already on our ecosystem that we acquired at that low cost of acquisition. That's just our timeline there. And that is me done with 10 seconds to spare. So enjoy your lunch. Thank you.
Thank you very much to all the speakers. It's now time for our networking launch. For those who are in Erasmus building, I kindly ask you to go in this direction. And for everybody, those in the room and those following us on ESA TV, we will reconvene at 1:15 here in the room. Thank you.